Good morning, friends. So, after a long gap, I am here. Welcome you in my channel, Animal Genetics by Dr. Gupta. So, in this lecture, I will be discussing about the mating systems, and in this particular part of lecture, mating system, I will be discussing about the classification of mating system, and in that, I will be discussing you about the 2-3 mating systems that we have to study in our BBS in AH syllabus. So let us start with the introduction. So, what animal breeder do? So, animal breeder will take mainly two decisions, that is the selection decision and the mating decision. For any breeding strategy, if an animal breeder is formulating a breeding strategy, he will take mainly two decisions, that is selection decision and mating decision. So what is selection decision? By selection decision, the breeder will decide which any individual to become parent in the next generation. Then how many progeny they will produce and how long be the parent utilized. So these are the three decisions that will be taken as a part of selection decision. Whereas in mating decision, the breeder will decide which males to breed with which females. So any animal breeder will take mainly two decisions, that is selection decision and mating decision. So in this lecture, we will be discussing about the mating system or the mating decision that breeder take. So mating system can be defined as a set of rules for making mating decisions. So we'll see on what basis breeder will take the mating decision. So first of all, we'll start with the mating system classification. So there are two bases on which mating system are being classified. The first one is the animal performance, whereas the second one is the pedigree relationship. So these are the two bases: animal performance and pedigree relationship. This animal performance means the phenotypic relationship between the individuals, whereas if you see the pedigree relationship, that means it is on the basis of genetic relationship, because the members of the pedigree, same pedigree, they will come share common uh, genetic composition, some part of the common genetic composition. So, in the first basis, that is on the basis of animal performance, mating system can be classified into three parts, that is random mating, the positive associative mating, and the negative associative mating. Whereas on the basis of pedigree relationship, the uh, mating system can be classified into two parts, inbreeding and outbreeding. So now we'll see each one of them in detail. The first strategy for making individual mating is the mating of a specific sire to a specific dam. That means when we have to take decision regarding mating, that means what we have to choose, we have to choose which male will be mated to which female. So in that, the first one is, will begin with the strategy that is in a sense no strategy at all, and that is the random mating. So random mating is considered as a strategy without any strategy. So let us see what is random mating. So random, as the name suggests, that it is a mating system in which any mates are chosen at random. Without any strategy, we will choose the mates. So, but still, because it is random, it is very difficult to uh, subside, or it is very difficult to hide your bias when you are performing, when you are going for random mating. So to cut short the biasness that we take, uh, when we will take decision, there will be some sort of biasness, it will creep inside that decision without our knowing. So to cut that biasness, there are many methods by which we can ensure the randomness. So the one such method is a random table. In any statistics book, you will see the random number table, on the basis of which you can generate random number, and then on that basis you can decide which male should be mated with which female. Another method is gate cutting method. Gate cutting method means it is a method mostly adopted in the Australia and New Zealand like country in the sheep breeding, where the sheep are divided into two. Means sheep is housed in a premises where there will be one gate, and the animal which first will appear on the gate, or the first animal which will cross the gate, that will be allowed to mate with the first number of male, or first number of female, and vice versa. So this is the gate cutting. Suppose this is the premises where the female animals are housed, and this is the gate. This is the gate. The first animal which will appear on the gate will be mated with, here we have put the male animals. So the first female animal which will cross the gate will be allowed to mate with the number one sire, or first number sire, and that this first second is also randomly we have assigned to the different males. So this is how the gate cutting works. There are many more methods. That means people have adopted many strategy to cut the biasness and to ensure the randomness. In Google also, if you will type the random number generation, then you will get you will be able to generate your own random number, and based on that you can decide which male should be mated with which female. So now the random mating, many times people get confused between the random mating and random selection. So this random mating is not actually random selection. Random selection is something different, and random mating is different. What is random mating? So for random mating, you have already selected animals. You have already chosen animals that are going to produce next generation. So for random mating, you don't have to perform selection. Only you have to decide which male should be mated with which female, and that is and that too in random mating it should be random. So whereas in random selection, you have to choose animals randomly to produce next generation. So these two are different. In random mating or in any kind of mating system, you have already chosen animal, already selected animals, so you don't have to perform selection again. So random mating can be either a lazy way to breed animals or deliberate, carefully chosen technique. So this random mating, it may be a lazy technique, or it is very deliberate or carefully chosen technique, because many times you will need random mating, because in random mating we will see next, it requires no performance record. First and foremost advantage is that for random mating you don't need any kind of records or genetic prediction. So simply you randomly choose few animals to or simply you decide which randomly which animal should be mated with which counterpart. So random mating is popular in commercial breeding program where performance information is unavailable. So when there is no performance information, you have to perform. You may go for the random mating. The random mating relinquishes less control than we think. So we are thinking that random mating is means we don't have any control. It is a simple technique. You choose or you choose any male and any female and allow them to mate. And the mistakes, then we think, and the mistakes that result from random mating are often balanced by pleasant surprise. So it is also said that in random mating, by mistake we are mating any of the male with any of the female, and in that way with the results, in many a times we are getting surprise in the results, and then we will utilize that surprise in the next generation, or for we will utilize that surprise further. So this was about the random mating. So it is a very simple method. You don't need any performance recording or any genetic prediction. Only thing is that you have to ensure the randomness. So for ensuring randomness, you can use random number table or gate cutting method, or you can generate your own random number. So, then next is associative mating. So associative mating means the mating of either similar individuals, that is positive associative mating, or dissimilar individual, that is negative associative mating. So again, associative mating may be of two types, positive and negative associative mating. When you are allowing the mating of similar individuals, it is called as positive associative mating, and if it is dissimilar individuals, then it is negative associative mating. So there are two types, positive and negative associative mating. Similar, what similar stands for? So similar means similar performance in a particular trait. So it may be those animals, they may be different in many in other traits, but they are similar in one particular trait. So that is called as associative mating. Associative mating require performance records, genetic prediction, or some other mating criteria. So this associative mating is very means you need performance recording. Without performance recording, you will not be able to perform associative mating. Now, the positive associative mating. So another, if you go for positive associative mating, it is the mating of biggest to biggest. Then coming to the positive associative mating, it is a mating the biggest to biggest, and the smallest to the smallest, and the fastest to fastest, and so on. So that means in positive associative mating, similar kind of individuals are being mated. What happens when you perform the positive associative mating? So in that case, if you see the normal distributed, the solid line, it represents the normal distribution of the population. Then after positive associative mating, okay, no, this dotted line presents the randomly mated population. When you perform the positive associative mating, you will see the mean is getting reduced. The mean is getting reduced, and the spread of distribution is getting increased. So what it indicates, it tends to create more genetic and phenotypic variation. When if you see it, this has spread, the spread of data is more. That means it is creating more genetic and phenotypic variation than it could be found in compared to randomly mated population. So in this case, in positive associative mating, the spread of data will be more, and you will get there will be reduction in the mean. So how it is possible? We'll see. In positive associative mating the highest to the highest and the lowest to the lowest, and tends to spread the distribution away from the center and towards the extreme. So here you can see the from center, the data is spread to both the directions. So how it is possible? This in phenotypic associative mating or positive associative mating, you will see here mates are chosen on the basis of their phenotype. So suppose for a particular trait is controlled by T gene. So there are three type of individuals: capital T, then capital T small t, and small t small t. Okay, I will write it again. This capital T, capital T, capital T, small t, and small t, small t. So suppose we are trying to mate two individuals with similar phenotype. So there is chances that these two, if we are taking the best animal, these two phenotypically they will be similar. So these two phenotypes may get mated with the similar kind of phenotype, that is capital T and capital T small t. So what will happen if these two are mated? What is the possibility of outcome? So outcome will be capital T, capital T, capital T, small t, and small t, small t. Now, if you see 75% of the individuals, they will be of dominant phenotype. That means they will be of favorable phenotype. Whereas 25% of the animal, they will be of recessive phenotype or unfavorable phenotype. So in this case, if you see slowly and slowly, the individuals from the lower side are also getting accumulated. Individuals from the inferior side, they are also getting accumulated, and this will spread your distribution. That means there will be a lot of variation. You chosen only the dominant phenotype, but ultimately you are getting all the three phenotypes. So that means your data distribution will be more, and the data will be spread, and your mean will be down. That means mean phenotypic performance will be lower. So this is the concept behind this positive associative mating. So what will happen if you see in the words, uniformity is usually valuable to breeder. In general, breeder will like uniform animals. Why it will like uniform animals? Because if he is in charge of a farm, or if he is posted, he or she is posted in a farm, the owner of a farm or the administrator, they will always appreciate when the animals are uniform, because they can miss the uniform animals. It will be very good for any kind of further selling or purchase, or for anything. So uniformity is usually valuable to breeder. So the increased phenotypic variation now, but in case of positive associative mating, there will be increased phenotypic variation. So generally it will not be liked by breeder. So this is called as the drawback of this strategy, positive associative mating. But increased genetic variation can be beneficial form of from a selection point of view, because we know raw material for selection is variation. So what we will get here, there will be increased variation. So you can perform selection in better way. So many a times when your motto or when your objective is to increase the variation for further utilization of that variation, then you may go for this positive associative mating. So positive associative mating therefore represents a way of spreading genetic change by increasing genetic variation. Mostly breeders use positive associative mating to produce extreme individuals. Here again, one more point you can see, in the both the extremes, you will see the individuals are getting increased, because the mean performance is getting down and it will getting increased towards the extreme. So when your target is to produce best animal or worse animal, best animals or worse animal, or you want to increase the even though the number will be less, but if you want to increase the extreme type of phenotypes, so in that case you will go for the positive associative mating. Mating to produce extreme makes sense if breeding goal is to change the mean performance of the population. So when your breeding goal is to increase the mean performance of individual population, when your breeding goal is to increase the mean performance of population, then you will go for positive associative mating. If an intermediate level of performance is optimal and uniformity about that optimum is important, positive associative mating is inappropriate. Suppose you want to increase the number of intermediate individuals or uniform individuals, then in that case, that if you want to create uniform animals, then in that case this positive associative mating is unuseful. You cannot use, because it will increase the variation and it will decrease the uniform animal. So this is about the positive associative mating. Similarly, in case of negative associative mating, you can see here it is a mating of biggest to smallest, and smallest to biggest, and fastest to slowest, and so on. So this is opposite to the positive associative mating. It tends to decrease the variation. So outcome will also be opposite to the positive associative mating. Here, there will be decrease in variation. What will happen in case of positive? You see the capital T here. This capital T is crossed with biggest, is crossed with small t, or biggest may be of two kind, the capital T or capital T small t. So what will happen in this case? You will see the most of the individual of out will be of this outcome. So this is the intermediate phenotype. So your intermediate phenotype individuals will be increased, and there will be more uniform animals. So this phenotype, there will be this genotype, there will be lot of animal with this genotype. Although other genotype will also be produced. Which genotype will be produced? Capital T, and small t, and capital T small t. Sorry, this small t. One second, I will draw. If you are mating this individual or this individual with this individual, so in this case the outcome will be capital T small t only this phenotype. So, or sorry, this also capital T. That means only the dominant phenotype will be there. Phenotype, I am not talking about the genotype. So only dominant phenotype will be there. So that means there will not be variation. So individual with similar phenotype will be increased. So here you can see in this graph, the mean has been increased and the spread has been reduced. So most of the animal, they will tend to come towards the mean. So there will be increase in the mean performance. So mating extremes in one direction to animals that are extreme in the opposite direction tends to produce intermediate types and reduce the number of extreme phenotypes. So this is what it has been expressed in this graph. Now reduced genetic variation decreases response to selection. Here in this case you can see there will be reduction in the variation. So reduction in variation, then it will be difficult to perform selection. There will decrease in the response to selection. If our goal is to increase phenotypic uniformity about some intermediate optimum, this mating strategy can be beneficial. If you want to increase the uniformity, suppose if you have been given a charge of a poultry farm, and in that poultry farm, the owner of that poultry farm wants that the egg size of this poultry farm should be uniform. And if you go, you went to that farm and you assess the situation, then you found that few individuals are producing 80 gram egg and few individuals are producing 30 gram egg, or 35 gram or 40 gram eggs. So in that case, what you will do, you will go for the negative associative mating. So you will cross the individuals with 80 gram of eggs to the individuals with the 40 gram egg or 35 gram egg. And in that this method, by this way, in the next generation, you may get some intermediate kind of egg, and whole of your flock will be producing the intermediate phenotype, or it may be around 60 gram or 55 gram or 50 gram. This negative associative mating is also called as corrective mating, because here in corrective mating, it is a mating designed to correct the progeny faults in one or both parents. So this is also a very important mating system, where you can correct the individual's defect. Suppose if in a horse, the hock joint, the angle of hock joint is very high. So this is high in one individual. In another individual, the angle is very straight, very straight, very straight. That means this angle is very less. Suppose this angle is very less and this angle is very large. So what is desirable? Desirable is the small angle. Small angle means not very small. It should not be straight, but there should be some angle. But it should not be that much deep angle. So what breeder will do? Breeder will cross these two animals, and resulting animal will have some optimum angle. So that is why this is called as corrective breeding. Corrective breeding, because with the help of these two extreme phenotype, with these two extreme type, we have created the intermediate phenotype. So this is the negative authoritative mating or corrective mating. So this corrective mating works on the breeding for complementarity. Complementarity means for a particular thing, some few individuals will complement. So what is complementarity? An improvement in the overall performance of offspring resulting from the mating of individual with different but complementary breeding value. So few individuals will be having higher breeding value in a particular area, and another individual may be higher breeding value in the opposite direction. So if these two individuals are being mated, this is called as complementary mating or corrective mating. So in this way, in this lecture, we have covered the classification of mating system. In that, on the first basis, that means on the basis of performance of animal, we have studied about the random mating and about the authoritative mating. In authoritative mating, there are two kind of authoritative mating, that is positive authoritative mating and negative authoritative mating. We have seen how to perform positive authoritative mating and negative authoritative mating, what may be the consequences of positive authoritative mating and negative authoritative mating. In next lecture, we will be discussing about the other mating system, that is inbreeding and outbreeding. Thank you very much.